Hello, everybody. So, we are first going to start by reading the question. A battery of EMF 7.8 volts and internal resistance R is connected to a filament lamp. We can see the figure. A total charge of 750 coulombs moves through the battery in a time interval of 1500 seconds. During this time, the filament lamp dissipates 5.7 kilojoules of energy. The EMF of the battery remains constant. Like always, I'm underlining the pieces of data given in the question because they will help us in figuring it out later which formula to use. First part, explain in terms of energy and without a calculation why the potential difference across the lamp must be less than the EMF of the battery. Now, let's have a look. This is a reasoning question which requires some explanation. Let's have a look at the circuit. There they have given us a source of EMF, which is a battery. Along with that, they have shown its internal resistance R, and the entire thing is in a dotted box, which means that the entire thing, 7.8 volts EMF source plus the resistance R, makes up the complete power supply or the main battery. So whenever there is a flow of current through the circuit, the current has to pass through the internal resistance as well. And whenever current has to pass through any resistance, we know that it needs some energy to help the charges pass through the resistance. So in terms of energy, whenever we have such a supply across any other external resistance or external component, we know that the potential difference available across this external component will not be equal to the EMF, the rated EMF of the power supply. And the terminal voltage available, which is the voltage available for the lamp, will always be a value less than the EMF of the main power supply, the rated EMF, like the one written on the battery. And by how much amount will it be lesser? By it will be lesser by an amount equal to the PD across the internal resistance. So if I have to explain it in terms of energy for 1 mark, I can simply write is all I can write is since some of the energy provided by the source is used up by the current in passing through the internal resistance of the battery itself, only the remaining energy is available across the lamp. So that is why the lamp will never get the same energy as being produced. It will always get an amount lesser than that.